So much to share with you today. Without further ado, please welcome our Chief Product Officer at MongoDB, Sahir Azam.
Good morning, everyone. Thank you for joining us despite some troubles with the weather. We'll see how it holds up through the rest of the day, but it's exciting to see such a big crowd here in Toronto. It's been a few years since I've been up here at one of our conferences meeting customers. So over the past few years, with you working with the industry and us as a business evolving, we've learned a few things. One, we've found that a digital-first strategy has become an imperative for almost every organization. Companies had to reorient their business. Every company's senior management team, every board was wondering how quickly could you pivot to the new digital-first reality. Retailers had to become experts at e-commerce. Gaming and streaming companies dealt with massive demand surges. And healthcare and pharmacy companies needed to rush medications across the globe in brand new ways. And time was of the essence. Speed was critical. And what many companies learned is that the fastest way to empower a digital-first strategy was with MongoDB, because we allow developers to move insanely fast. We allow product leaders to seize new opportunities and get to market faster. And we allow executives to plan for the future and respond to new threats. At MongoDB, our core ethos is all about developer productivity. It was from the first day when our founders started the company almost 15 years ago. Every strategy, every product we build is centered around this core tenet. So the obvious follow-up question is, what holds back developer productivity? And what our founders found and learned in their jobs and what they saw with their peers across the industry was that it was the friction of working with data. We see developers struggling with leveraging your proprietary information, the valuable information of your organization, to empower these customer experiences. So we built a company focused on removing the friction of working with data. Over the past 6 years, I've had the privilege of meeting thousands of customers, executives, architects, developers, CIOs, and CTOs. They've told me many things, asked for many capabilities, given us a lot of great feedback. But there's one thing no customer has ever complained about. I've never heard a customer said that they're innovating too quickly. Everyone is struggling with finding ways to move faster. They're held back by brittle legacy technology. And that's why MongoDB is becoming so popular. And it first and foremost all starts with the document model. It is the document model and our underlying architecture that enables this scale and this productivity inside of their environment. Now, there were many naysayers years ago who couldn't believe there could be a non-relational, document-oriented database that could be general purpose, that could support a wide array of mission-critical use cases. But developers said something different. And in fact, there have been more downloads of our software in the last 12 months than there have been in the first 12 years of this company's history. Now, in 2016, we released MongoDB Atlas. Atlas gives us the ability, sorry, a little bit out of sync here. Key inflection point with Atlas. People thought we were crazy to try to partner with major cloud providers while also competing with their first-party database providers. Nobody had built a meaningful business at scale trying to do so. But by 2017, we had over 2,500 users a week signing up, building a broad array of use cases, from systems of engagement to systems of record to systems of insight, all on this new platform. And we partnered heavily with Google Cloud, AWS, and Azure on making sure we have a seamless experience, working interoperably with their services, but also giving you a frictionless procurement experiences by integrating with all three marketplaces. Now, today, we actually see 160,000 developers signing up for MongoDB Atlas every month. It's used by the majority of our customers, and it is by far the fastest growing part of our business. You're going to hear a lot about Atlas today. Now, we're fortunate at MongoDB to work with 39,000 customers and growing across the globe. We have the privilege of seeing use cases across every industry, every organization of any size, from the most innovative new startups through to the established global brands who are working worldwide across multiple countries and geographies. To give you an example, we have companies like Toyota who built their connected car platform on MongoDB Atlas. Organizations like Diageo, who's known for Johnny Walker, Guinness, and of course Crown Royal, uses Atlas as the backbone of their digital strategy, bringing disparate systems together in the cloud and enabling their streamlined customer experience. And right here in Canada, we have financial services with Manulife, who migrated mission-critical applications to Atlas, driving a 10x performance improvement and reducing operational costs by 30%. And of course, Loblaw, founded over 100 years ago with broad reach into retail, grocery, finance, pharmacy, healthcare, and logistics. A true conglomerate. They use MongoDB for mission-critical applications across their organization. And in fact, if you want to learn more, check out Sarah Willock's talk today at 11:25, talking about their journey to MongoDB Atlas and how they've optimized their digital-first experience. Now, we're very proud to have all these amazing organizations working with our technology. But the reality is, we are just getting started. Every day, every one of us touches MongoDB and interacts with it in some way, shape, or form. But we know that software is only growing in our ecosystem and industry. And that's why we're doubling down. And in fact, we are very serious. We are spending more in engineering and research and development this year than we spent in the first 10 years of the company's history. And that's because we're focused on empowering innovators everywhere to be able to create, disrupt, and transform their industries by leveraging the power of not only their data, but with the amazing software they can build on top of it. Now, over the past 15 years, what we've learned time and time again is that friction still exists. And that friction starts with the limitation of traditional database systems, which are rigid, inflexible, costly, and hard to scale. And we see organizations struggle with leveraging this 40-year-old approach while building modern applications of today. In order to solve this problem, we see organizations surround their relational database and traditional systems with a variety of niche technologies to solve the different use cases that modern applications require. And what we see with organizations that rush headfirst into the cloud, giving their developers and their architects full access to any service they want, is that they end up with this mess. Multiple technologies, a disjointed developer experience, data duplication, a whole breadth of surface area to secure and operate. Who the heck wants a data architecture that looks like this? It fundamentally slows down innovation. So we stepped back and recognized that the market needs something different. We went back to first principles and said, if we want to solve this sprawl, this complexity that it gets in the way of developing amazing applications, what do we need? The first thing we recognized is that the world needs a platform for innovation that gets the plumbing and complexity of data out of the way. And the first key tenet of this platform needs to be an elegant developer experience. That means leveraging a modern data model, working the way modern programming languages work, and fitting into modern development approaches and pipelines. Next, it means supporting a broad array of use cases. So you can support most, if not all, of the application requirements across your organization. You should be able to support these workloads on premises or in any cloud of your choice. And we need global reach and scale. Today, our customers are interacting with our technologies across the world. They could be in Canada one day and London the next. How do you deliver a secure and performant experience no matter where your end customers are? All of this wouldn't matter, however. All these capabilities would not be matter if we did not have a foundation of scalability and security. And that's what we built with Atlas, the industry's first developer data platform, which gives you a single unified interface that supports a broad array of workloads and applications and is on a foundation of elasticity and consumption-based cloud economics. This is great if you have a small team. But many of you, as I know, have hundreds of teams in your organization, all operating on different microservices, different parts of the architecture. How can you drive innovation in that style of an environment, where data isn't locked in silos? How do you make data a cross-company asset that can be leveraged to build any application? You need standardization. You need a technology stack that everyone understands, can leverage, and can simply share information across an organization and enable that continuous delivery automation line, end to end. Now, a great example of a company that's gone headfirst in this approach is Caban Games, right here in Canada. They're a leading mobile game developer. I visited them a few years ago in Vancouver. I was excited to see some of the folks here again in Toronto. And they've had huge games such as Marvel Contest of Champions and Disney Mirrorverse. They chose MongoDB because of its flexibility, the document model, and the ability to scale horizontally. It's a great fit for their massive scale applications with millions of gamers using the technology every day. And the best part, they can scale and manage these dozens of clusters with one single and lean SRE team. Check out Kabam's story later today at 1:40, where they walk through their journey on using MongoDB, first open source and then into Atlas. Now, let's talk about what we're working on and what we're recently announced. I talked about first principle for us being elegant developer experience. How do we help organizations take something from an idea to production as fast as we can? This is something we see as a trend across the industry. And in many ways, modern development is a story of simplicity, of removing layers and layers of complexity by adding higher levels of abstraction. We've seen physical servers give way to virtual machines in the cloud. We've seen virtual machines give way to containers, and now we're seeing new modern forms of serverless development across the globe. This is all fundamentally about getting the complexity out of the way so you can focus on innovation. And we're seeing the whole industry move quickly in this direction. In fact, analysts predict that there will be $40 billion of market share happening as organizations shift from traditional compute infrastructure to modern serverless and container-based architectures in the coming few years. But as we looked across the data landscape, we saw that most serverless databases left developers wanting more. Existing options are often quite limited in functionality. They're rarely ever the heart of the application. They're just another niche technology bolted for a particular microservice. They're oftentimes forced a scaling trade-off, where if you want to save cost and scale to zero, you can, but if your application spikes back up, you have to pay for a cold start delay tax and have your application slow down while it's catching up. We see costs often scale linearly in unpredictable ways based on the workload. And of course, there's immense lock-in, because the majority of serverless offerings today are proprietary and lock you into a single cloud provider. So this past summer, we were excited to release the general availability of Atlas Serverless. And with Atlas Serverless, our goal is to provide a serverless database without those compromises. So we worked hard on focusing on a few key areas. One, making sure that we can enable the full power of MongoDB. Strong consistency guarantees, rich secondary indexes, all the capabilities we've built up over the last 15 years. Second, we built an architecture that doesn't force a scaling trade-off. You can scale down to zero if your workload isn't using the service at all, but quickly scale back up if your workload ramps. We worked on an innovative pricing model that gives out-of-the-box usage-based discounts as your application scales, caps the workload for cost for reads as well. And we give you full deployment and cloud flexibility, running across AWS, Azure, and GCP. We're super excited to empower these next-generation applications, event-driven architectures, working seamlessly with technologies such as AWS Lambda or Google Cloud Functions to enable these modern next-generation applications. So please give it a try. This is a seamless part of the Atlas experience. Next, I talked about how our platform needs to support a broad array of workloads so you can drive standardization in your organization. Now, in order to show the breadth of the capabilities and what a typical modern application needs, we thought it'd be fun to go through an example. So we created a fake application example called Leafy, which is a hypothetical marketplace to buy and sell houseplants. Don't worry, MongoDB is not pivoting its business model. This is just an example. So Leafy is a dual-sided marketplace. There's really kind of three constituents that we think about here. We have the sellers who are growing plants all across the globe. They want to be able to sell them and reach customers no matter where they are. There are, of course, buyers who want to find that perfect plant for their home, their office, to make sure that it matches their lifestyle. And of course, Leafy Corporation, the company that set up this innovative dual-sided marketplace. Now, Leafy Corporation's application, like many of your applications, needs human-readable search capabilities to allow end users to interact seamlessly with the application. In this case, you can see a very simple example. I'm searching for indoor houseplants. But even enabling something simple like this oftentimes requires a complex architecture. Your application needs multiple drivers, multiple authentication schemes to connect not only to your operational database cluster, but also a separate search cluster. And then there's the hidden cost of maintaining that sync pipeline or stream that keeps data integrated between your operational system and something like Solr or Elasticsearch on the search side. We've seen this actually drag down development velocity by up to 20 to 30% in some organizations. And so a few years ago, we started investing heavily in Atlas Search. It is the easiest way to enable Lucene-based full-text relevant search into your application. We integrated the power of Lucene behind the MongoDB API and remove away all the operational complexity. So it just feels like a feature of the database. And for the past few years, we've been investing in making sure we add more and more capability: synonyms, source fields, facets, and other capabilities. Two of the most recent ones that we're excited about are facets. Facets are a part of almost every search application experience. You want to be able to count, filter, and sort information quickly. With this new feature in MongoDB Atlas, these queries are now 100 times faster than they were before. We also enable the capability called More Like This, which allows you to create recommendation features that finds disparate systems and parts and recommends them to your end customer, even if they have different search terms underneath. Now, after I've built my search for Leafy Corp, I need to figure out how my end users actually interact with this. And of course, many applications today are mobile first. We all have a smartphone in our pocket. We may use a tablet when we're traveling, and of course, a web browser as well. The problem is creating compelling reactive mobile experiences is complicated. You need to manage not only the data on the client or the phone, you need to be able to figure out how to synchronize that back to a variety of different cloud services and data in the cloud, and you need to deal with a bunch of error handling. This sounds simple, but what we found from many organizations is that just dealing with the complexity of retry logic, conflict resolution, data consistency across APIs can actually take mobile development teams 40 to 50% of their time. And yes, if your business is a mobile application, if you're Facebook or Instagram or one of the large organizations that have thousands of mobile developers, this might be a tenable problem to build around. But for many of us, our mobile teams are quite small. So how can we empower them to focus on building great experiences? And the answer is by removing all of this plumbing and all of this complexity and just making it automatic. So 2 years ago, we acquired a company called Realm. And Realm had built a database for mobile environments and edge devices. Their capability allows developers to work extremely fast while building mobile applications, but make it seamless and configuration-based to synchronize that back to the cloud. So this year, we're excited to announce the GA of Flexible Sync, a granular mechanism for controlling exactly which end client can have access to what data based on the role of the individual using that particular application. All done by defining a query, no custom code needed. We also enabled asymmetric sync. This is great for IoT applications that are collecting information from a variety of different environments. For example, we work with Verizon on connecting information from robots in agriculture fields that are taking samples and streaming that back into the Atlas platform. And new SDKs for Kotlin and Flutter. The mobile development ecosystem is changing fast, and we want to make sure we're supporting the languages that are most pervasive and that customers are building on in the future. So I've got my search use case sorted. I've got my mobile integration and my end user client experience sorted. What else do I need to build here? Well, most applications today want to provide a compelling end user experience with a variety of real-time information. You're not just looking at a particular record, but you may want to aggregate information to have more complex queries. In this case, I want to show, for example, what the latest price in the marketplace was for this particular plant. Or as a seller, I may want to understand in real time which of my plants are selling where across the globe, how much revenue I'm collecting for it. And oftentimes, these queries are very different than a traditional operational point query. We refer to this as in-app analytics, complex query shapes aggregating multiple sources of data, not for reporting and analytics alone, but to power the application experience. Unfortunately, standing up this kind of rich customer experience is expensive. It takes a variety of different technologies. You may have an operational database like MongoDB. If you're dealing with time series database, a separate technology there. A real-time analytics database, a bunch of ETL pipelines to tie it together, and probably even a caching technology to merge that into a performant user experience. All of this is extra systems, extra moving parts, stale data, and duplication. That takes away time and effort, again, from innovation. Now, we've been focused on solving this problem at MongoDB for many years. In 5.0, we added window functions. You could have simple calculations such as moving averages and cumulative sums. We added new accumulators like top and bottom that push more processing down to the database so it simplifies your code and makes it more performant. And we added analytics nodes in Atlas, allowing you to isolate and separate out these real-time analytical queries away from your transactional workloads, so there's no contention of resources. Now, we've had thousands of customers stand up analytics nodes in Atlas in the last couple years, and the number one thing they've asked for is the ability to fine-tune those analytics nodes with specialized hardware. So you can have a different profile all within the same cluster of CPU, RAM, and memory, powering these analytical query patterns as distinct from your high-throughput transactional workloads, all with a click of a button. Now, oftentimes these in-app analytics queries require joining multiple sources of data across multiple collections. So we've had lookup in MongoDB for quite some time, and we've been investing in it release after release, adding broader sharded cluster support, and more recently, making a big investment in performance in 6.0. I'm excited to report that now sharded lookups are now anywhere from 2 to 100x faster, allowing you to merge multiple collections together, powering these large aggregations in your application experience, building more compelling, more differentiated experience. Now, it's not good enough to only store data in an operational system and be able to run these types of fast analytics. We also need to optimize aggregations without having to deal with pulling back documents every single time in a traditional row-based manner. So we are now adding column store indexing to MongoDB. This allows you to run aggregations of a single field across multiple documents in a much more performant way than dealing with our traditional storage techniques, which are optimized for operational transactions. This can make analytical aggregations 15 times faster, moving queries that traditionally could only be used for reporting and business intelligence into the application experience to drive further software automation. Now, if I step back to my leafy example, I'm going to go back to my seller dashboard. And if you look closely here, that bottom chart of price history is actually tracking my price over time. And what we've seen across manufacturing, IoT, financial services, just to name a few industries, is that time series data is growing exponentially. And we're expecting to see that even more over the next decade. And so we've seen a variety of different technologies spring up, optimized for this specific type of use case and data set. But many of our customers said to us, why do I have to stand up a separate database for my time series information? I would love to use the richness of the document model, which is the natural fit for time series, but with the performance and ease of use of these niche technologies focused on that use case. So in 5.0, we released time series collections. We allow native operators that allow bucketing and querying of time series data, and enhancements to the efficiency and storage performance of that type of data. And again, we've been investing quarter over quarter in making this better, from sharding support to compression to gap filling and most recently, read performance and indexing improvements. This is one of the hottest new features in our platform. We've seen intense uptick in just the first year, so you'll see us doubling down and adding more capabilities as we move forward. A great example of an organization that's leaned in with us on this time series development and helped us figure out the right roadmap is J.B. Hunt. They're one of the largest fleet operators in North America, and they leverage time series data to get real-time information into the load status and available capacity on their network. This is crucial in a time when our global supply chain is under pressure. We're very fortunate to work with them on trying to ease that and move goods across the continent. So to summarize, MongoDB Atlas is now a unified platform for these real-time in-application analytical use cases. With analytic node tiers, with faster join and dollar lookup, column store indexing coming soon, and native time series support, all in a single platform and system. Now, coming back to my Leafy example, I talked quite a bit about sellers trying to distribute their plants and buyers and how they want to log onto their mobile devices and buy them anywhere they are. But let's talk about Leafy Corporation itself. If you're building a successful business, it's not just the teams developing the software and operating it. There are many others that are required to build a successful organization. You have business analysts that need to create reports to understand the health of the organization. Data scientists who run models to help better decision-making and predictions for the future of the health of business. And of course, data architects and engineers, gluing all those systems together and making sure the right data gets to the right person at the right time. When we talk to these personas inside of our customers' base, they tell us there's multiple ways they look at information. One common pattern is, of course, they want to look historically. They want to look backwards in time to compare performance of the business or the application over time. Very simple example here of looking at sales 1 year over another. For Leafy, this is a pretty common use case. The other, of course, is long-term planning. They use models to want to predict where the business could go and run scenario planning so executives can make decision-making. Now, cobbling all this together is generally a solved problem in an organization. You dump all your data into a data warehouse typically or a data lake, and you generate business reporting off of that. The challenge, though, is there's one key piece missing. And that's getting a real-time view of what's actually happening in the business, in the application right now. And as the world of business is more digitized, decision-making needs to be much faster than waiting a week for a report or a month for a report or a projected analysis. Product managers, engineers, executives need to make decisions oftentimes within the span of hours or days. And we saw an opportunity to make this much, much easier. We wanted any business to enable a real-time view of what's happening, either in the application experience or through traditional reporting technologies, simply in our platform. And the reason we saw this as a problem is, of course, that enabling a real-time environment is another complex mess. You have multiple database systems, multiple ETL pipelines, multiple caching technologies, just to serve these different personas in an organization. We felt there had to be a better way. And so, to walk you through this, I'm very excited to welcome Joel Lord, a developer advocate at MongoDB, who will talk you through some of the latest capabilities we have in empowering others with the data we generate in the MongoDB platform. Joel?
Hello, everyone. I'm very happy to be here. My name is Joel. I'm a developer advocate at MongoDB. As a developer advocate, my job is to make software developers' job a little bit easier, which is why I'm so excited to introduce you to two new features today, which I think really have the potential to change how you use and interact MongoDB Atlas and the developer data platform. Now, if you've been introduced to Leafy Corp already, you know about them. It's an international organization that enables users to buy and sell plants online. Now, they have this need for a real-time dashboard, but international is the key word here. All of their sellers are selling all of their plants in their local currency, but we need to report back with this dashboard to our headquarters in Toronto in Canadian dollars. So data federation is the first feature I'll introduce today that enables you to make it a lot easier to get access to real-time data to make those calculations. Let's head over to the Atlas UI, and you'll see that there's a data federation menu item right here, which I'll just click to, and here I am. So from here, I can create a new federated database. Now, a federated database is a virtual cluster that will contain virtual databases that will in turn contain virtual collections. Now, that's a lot of virtuals. I'll get to that in a couple of seconds. By the way, I'll be using the GUI for this demo. Marketing people think it's a lot prettier to use the GUI, but be assured that all of this can be done either using the CLI or any API, as well as configuration as code if you need to. But I'll stick to this for now, and I'll go ahead and create my first federated database. Speaking of making things pretty, I'll change that name to something a little bit more meaningful here. I'll call this Leafy Lake. This will be a little bit prettier when you take a picture and you tweet about it in a couple of seconds. Good. I'm glad you got the message. So let's start by adding our first data source here. Now, Leafy Corp already has all of their data stored in Atlas clusters, so I'll use this Atlas cluster to get access to our live production data. From here, I can choose which cluster I want to use. I'll just use the one cluster that we have. This will retrieve a list of all the databases and collections that are available to me. I can expand this list and select whichever collections I want to add as a virtual collection. Just click Next. Now I'll start by creating my first virtual database. I'll again rename it. We'll call this one LeafyDB. And I'll also rename my virtual collection to sellers. So we'll create a virtual collection of sellers. For the source of this virtual collection, I'll use the production data and the production collection called LeafyDB.sellers. Now, note that this is not copying the data over. What it's doing is that it's telling the federated database that any incoming query to this virtual collection should be done against the real production collection. OK, so now that we've got this, and I know I said I was going to use the GUI, but sometimes the CLI is a little bit better. So I'll switch over to my CLI. I think Mongo Shell is a great tool, if you're not familiar with it, to connect to your Atlas clusters, and then you'll be able to query data. I think it's a little bit more visual as well, especially when it comes to these type of demos. So I'll connect to my cluster. I'll just provide it with my credentials. And I'm now connected to my Atlas cluster to the visual Leafy database. From here, I can list the collections that I have. I can see Show Collections. And you will see that Sellers virtual collection I've just created. If you're familiar with the MongoDB Query API, you know that I can query by using find one, which is what I'll do. This will retrieve one of the documents inside of this virtual collections. I'll do DB Sellers, find one, and we've got our first seller. So you can see that we've got this seller, Superplants, selling roses, and they're using US dollars. And as I said, we want to report back, but we'll want to use Canadian dollars to report back to our dashboard. Now, this can be done by adding an additional data source, which is what we'll do right now. So first of all, I'll create a second virtual collection. I'll call this one Live FX Rates. And I'll add a second data source. Now, I've shown you how to use an Atlas cluster as a data source. That works out very well, but there's two other sources that I wanted to introduce to you today. The first one is an Amazon S3 bucket. That means that you can take any JSON, BSON, CSV, or even highly compressed Parquet files stored in an S3 bucket and query them as if they were a collection in your cluster. So that can be very useful, especially when it comes to historical data that you've stored somewhere over there. But there's something even better, in my opinion. You can actually query any URL that would serve one of those file formats. And we have a name for a URL that serves JSON objects, right? APIs. So you can add an API as an external data source that you could then be able to query as if it was a collection inside of your cluster. So Leafy Corp subscribed to a service called livebizData.de, which will provide them with real-time foreign exchange rate data. With that, they'll be able to query their current collections and do calculations to get the current value in Canadian dollars. So let's take a look at how this looks like. So I'll start by giving it a name. I'll call this one Live FX Rates. And I'll just paste in the URL, the endpoint for my API. I can click Next. I'll just drag this one over again. And we've got this second virtual collection. Again, let me switch over to the CLI to see what this looks like. From here, I can do the same thing as I did earlier. I can do Show Collections. And in this case, you will see that there are 2 virtual collections. So we now have access to that live FX rates collection. So what does it look like when we start to, or we try to query this collection, which is actually querying an external API? So I'll do a find one on this one again. And there you have it. This is the response that we would get if we were to do a GET request on that specific API. You can see that I have all of the metadata that I would get from that response, as well as the rates object, which is provided to me by livebizData.de. Now, if I try to query this data again, you'll notice that those numbers might change just a little bit. This is because it's a live API providing me with real-time data concerning the currency and the exchange rates. So if I query this again, there you have it. The numbers change just a little bit because, again, it's real-time data. Now, this is nice, and it gives me a lot of power. I can now query this external API. However, the format in which I'm receiving this server response is not ideal for my calculations. What I'd really rather have is one big collection that would contain one document per currency, and then I'll be able to use those in a lookup operation. Now, I guess we could call livebizData.de and ask them to change the way the API works, but that's not probably going to work. So we have a solution for that. So let's go back to our data federation screen and add what we call a view. I'll give this view a name, and I'll provide it with an aggregation pipeline. Let me just paste it in here. So in here, I've got an aggregation pipeline that will take this rates object. It will then unwind it and create all of those documents that I need. You can take a look at the recording later on if you're interested in the aggregation pipeline. If I switch back to my CLI again, I run this show collection one last time. You can see that we now have this FX table. So it acts as if it was a collection inside of our MongoDB database. And I can run a find operation on this. And there you have it. So what just happened is that I actually did a query against an external API on another server that has their data on another database. And it then automatically took that information, transformed that in a way that I can now use for my calculations, and I can access very easily. Now, there's one last thing that you might want to do with that note. And that's not true. We need to do those calculations for our dashboard. So I already talked a little bit about what this would look like. So what we'll need to do for this dashboard, we'll need to build an aggregation pipeline. There's a few things we'll need to do here. First of all, we'll need to do a dollar lookup. So now that we've got our sellers collection as well as our FX table that provides us with the exchange rates in the format that we need, we can do that lookup operation, get that exchange rate, and add that to our documents. From there, we can use a dollar divide to calculate the price in Canadian dollars. And with that, we can do a dollar group operator to get each individual plant and then get the current inventory, the total value of the inventory, as well as the maximum and minimum price in which they are traded right now in real time. The aggregation pipeline itself looks a little bit like this. So you recognize there's the dollar lookup operator there, the dollar divide and dollar group. You can take a look again at this aggregation pipeline afterwards. But if I run this aggregation pipeline, there you have it. Now I have access to all the data that I need. I have access to all those plants. And it did this query to an external API to fetch the real-time exchange rates to provide me exactly with the data that I need for my dashboard. Now, this is great, but maybe you don't want to get access to that live real-time data every single time. Maybe you want to create a monthly report. So you'll want to take a snapshot of that data and store it somewhere else. So there's one last thing that you can do with data federation, which is to add an outstage. By using an outstage, you can take that snapshot and store it either in an Atlas cluster or in an S3 bucket somewhere. So this is what my outstage would look like. And now I can take my original aggregation pipeline, just add this final outstage to it. And all of my data is now saved into this external Atlas cluster, which can then be used for downstream processing or to send to my stakeholders. So if you're a software developer, you're already familiar with the MongoDB Query API. You know how powerful it is, and our customers generally really like it. But there's one thing that we keep hearing all the time. This is nice. Our software developers can now build dashboards. However, our business analysts don't generally use MongoDB Query API. And when we ask them what do they use to query their data, it's always the same answer: SQL. Well, I'm very excited to introduce this other feature called the Atlas SQL interface, which lets you take a SQL statement just like that, where I'm having my select statement, and you can see that I'm querying data from the virtual collections that I've just created, including that FX table, which does that request to the external server. And I can now run this. And voila, I get the same results again, but this time all of this was done with SQL. So this lets your team use familiar tools that they already use and love, and to be able to still do those same requests directly against a MongoDB instance. It lets your data science team use Jupyter Notebooks, or your back office reporting team use Excel, or even your business analysts use Tableau or SAS. All of this is being done by using your familiar tools that you already use. So you've seen how you can, with data federation, get multiple sources and create those rich virtual collections that would even include information that comes from an external database into your Atlas cluster. You've seen how you can query those either using the MongoDB Query API that you're already familiar with, or even using SQL as if it was a traditional database. I, for one, can't wait to see what you will build with this. And with that, I will leave it over to Sahir again. Thank you.
I can't wait to see how you leverage the new capabilities that Joel just walked through. But as I mentioned earlier, there's much more than developers. So we focused heavily on making sure that Atlas can serve the entire data lifecycle for your organization. With Atlas Data Lake to store large volumes of data efficiently and make it easy to query for analytical workloads. Data federation, as you just saw, which allows you to combine multiple sources of data into virtual collections without ETL pipelines moving everything around. Atlas Charts, which allows you to create native document-oriented dashboards or embed those visualizations in your applications. And of course, the new Atlas SQL interface, which empowers other users with the tools they love to interact with the data generated in our platform. Now, this Atlas suite of capabilities that powers the Leafy application example here is representative of what we see in many organizations, certainly at more complex scale and different varieties across every industry. And we're trying to build an integrated platform that gets the plumbing out of the way so you can focus on building the logic, building the business application. But one of the things we hear time and time again from customers is that they're struggling with security. The threat vectors continue to become more complex. Global privacy regulations strengthen day after day, which makes it harder for us as technologists to wrangle and understand how to manage all of this data. However, keeping data secure is mission critical. We have to be stewards of our customers' data. Now, obviously, there's a variety of different ways that most technologies accomplish this. You have encryption, end-to-end, perhaps from your client application to your database using networking-based encryption like TLS, and of course, various technologies to encrypt the storage of the data on disk. Storage encryption at the snapshot level or disk-based encryption on the instance itself. The challenge with this is that your database administrator, whether that be a cloud provider or the operators within your own organization, still can have access to the information because the key to decrypt information is on the server. That leaves it vulnerable to server-side attacks, to privileged users that may be outside of your organization. In 2019, we tried to solve this problem by enabling client-side encryption, which moved the key out of the control of the server operators and into the application developers and application teams alone. This allows you to create that separation, and it empowers certain use cases to move to the cloud, for example, more easily. However, there's a pretty big trade-off. Once data is encrypted on the client side, the server can't understand it, so you can't enable complex expressive queries. But imagine you could actually enable true encryption in use, meaning you get the value of having a single key that you control, but still allow for expressive queries and the value of leveraging that data with the power of MongoDB. 2 years ago, we brought on a team of researchers from Brown University who were leading investments into structured encryption. And for the first time, we're excited to announce the enablement of queryable encryption. This is an industry first. It unlocks mission-critical next-generation security for the most confidential workloads. It allows for client-side encryption, but without allowing the server to have any information about what the data is processing is. And this enables a countless set of use cases as customers move faster to the cloud. Let's talk about how it works. First, your client driver that your developers use acts exactly the same. In this example, I have multiple billing records that tie to a single individual with an SIN number. So this social identity number can be found across multiple documents in my database. It gets encrypted in the client, so by the time it gets to the server, it's just an encrypted hash. Now, as I mentioned, I have multiple records for the same individual with the same social identification number here. However, the hash is actually different. So not only can the database itself or the server-side administrators not see the information because it's scrambled, even for information that's the same, they can't tell it's the same because each hash is unique, providing an extra layer of security. When you want to decrypt that data, it gets shipped back and decrypted at the client side, where you can now see the data in plain text, back in these SIN numbers you can see here. The magic, of course, is how do we actually enable this level of encryption on sensitive fields while still allowing rich queries? We do this through an open and published set of algorithms that were invented at Brown and implemented for the first time, leveraging structured encryption in MongoDB. Today, in the preview, we can enable equality matches. But over the coming quarters, we're enabling range queries, prefix, suffix, and other broad arrays of search capabilities on this data. So for example, if you're a healthcare company and you want to quickly find patient records that start with a particular set of characters, you can now do so without the database having any access to that information. This is groundbreaking for security in the cloud. So please give the preview a try. We have experts that can walk you through how we enable this. We're excited over this multi-year investment to see where it takes our industry. Now, I talked a lot about many exciting features: search, operational database features, in-app analytics, and of course, security. But we know that many of you can't leverage these capabilities easily because you have legacy applications, storing information in legacy systems where your data is locked up and hard to manage. Now, we know that change is hard. It's hard to modernize an application, to transition and migrate an operational mission-critical database, especially when you're dealing with a monolithic data model where you have hundreds or thousands of tables all connected together that are very complicated to reason about and hard to peel apart. And we worked with customers over the years, over the last decade, to move from traditional rows and tables into a natural data model that allows those developers to move faster. Not only is it more efficient for the developer, it's also more efficient on the hardware. That right side document only has 2 IOP operations versus a simple 3-table example here has 6. So it makes the environment much faster and more efficient and more green as well. And over the last 10 years, as we've worked with customers, we've seen this drive 3 to 5 time improvement in development velocity and up to 70% cost savings versus traditional database systems. Sounds great. However, as I mentioned, it's hard. We're trying to make that easier. So this year, we announced Relational Migrator. This is a technology for MongoDB that allows you to connect and analyze a traditional relational schema, understand the tables and relationships that exist, with a visual campus to design and map that to a MongoDB document-oriented schema. You can run scenarios, you can embed information, and see how you can get that data model to be cleaner and much more natural to work with for your developers. Once you map the schema, you can provide a one-time migration or a continuous migration from your source system. This is a technology we're leveraging first with our consulting services and our solutions architects to help customers give feedback, but we'll continue to invest here and make this a technology that we enable natively in Atlas in years to come, to make it easier and easier to get smarter recommendations on the right object-oriented data model in MongoDB. To learn more, please check out Shiv's talk right here at 3:45 today, which talks about how you can move relational workloads to MongoDB with confidence. Now, to summarize, we've been focused heavily on how we can empower you to take an idea and build the next generation global application. We want to be able to unlock the ideas and the potential that any development team wants to create and make it simple to enable that across millions of users. But to enable those skills, we actually needed to invest in a different way. So back in 2012, we enabled MongoDB University. And by 2018, we had 1 million registrants take advantage of the knowledge we had created in that technology platform. But online learning has changed a lot. The next generation of developers learn in different ways. And so we felt that it was time to modernize. So for the last year, we've been working on the new MongoDB University with revamped course curriculum, a fully integrated lab environment, all information fully ungated. No matter where you are, you can access it on our platform or a variety of partner platforms. It allows you to build a comprehensive MongoDB skill set, not just with the basics of the database, but with the entire data platform. And we'll be continuing to add more and more content over the coming years. And now you can get certified in a matter of hours instead of weeks or months with our prior platform. So take a picture, bookmark the link, and check out the new MongoDB University. It's all free. Now, in order to enable a developer data platform that can enable global reach and scale, we need to focus on reach ourselves. I remember when we launched Atlas many years ago, we were only in 4 regions, but now we are the most available cloud data platform in the world. We are in 103 or 104 regions, working in tandem with our partners, AWS, Azure, and GCP. And this gives us an incredible view of the worldwide development industry. Every week, we see 25,000 new ideas spring to life on our platform. Just in the last few months, we saw a healthcare company in Norway creating a simulation training platform for healthcare workers. We saw a challenger bank in Vietnam enabling a digital-first financial experience for Southeast Asia. A startup in Chicago reimagining social networking and dating. A nonprofit in Mexico taking surplus food from restaurants and distributing it to the poor. And an NGO in South Africa outsourcing agriculture investments. And every week we see different ideas and new businesses spring up all across the globe, across all of the different regions that we reach. So all of us at MongoDB, I hope you get to meet many of our team members here today. We're very lucky and humbled to empower these amazing experiences you create. We cannot wait to see what you build next. So please, enjoy the content today, join the different sessions. We've got a rich set of knowledge, a bunch of customers educating on what they've done with our platform today. Please enjoy MongoDB.local. Thank you.